Alright, so today's video is going to be all about index notation and index laws. You may or may not be familiar with the word index in this sort of math context. When you see index or indices, which would be plural, just think exponents. So we're going to start by introducing exponents, and then we're going to look at some laws about how to use them and how to make things a little bit easier when you do use them. So first off, index notation. Think notation, think the way you write something. So we're going to look at how do you write indices, or how do you write exponents. So when we use exponents with algebraic products, so remember algebra letters, it's exactly the same way as we would use them when we use exponents with numbers. So we write the algebraic product in what's called index notation, just because it's a little bit easier than writing out the same thing multiplied by itself however many times it is that we're looking at it. So, for example, in the same way that 4 to the power of 3, or 4 cubed, means 4 times 4 times 4, a to the power of 3, or a cubed, means a times a times a. Don't get confused. It doesn't mean 3 times a. It means a times itself 3 times. So, a to the power of 3 is the product of 3 a's. It's not the product of 3 times a. It's the product of 3 a's. So now we're going to look at some index laws. So law number 1 is when you're multiplying exponents together. When you're multiplying powers, when you're multiplying indices, however you want to term it, we're looking at what do you do, how do you multiply them together. So to multiply powers that have the same base, and that is key. The same base. They must have the same base, or else this law doesn't apply. So when you're multiplying powers that have the same base, you keep the base and then you add together the indices, or you add together the exponents. So what does that look like? So if we have p to the power of 4 times p to the power of 5, you can think of it as, okay, well that's p times p times p times p times, so that's p to the power of 4, and then we've got the same thing 5 times. Okay, so we've got p to the power of 4, the first 4, times p to the power of 5, so the second 5. So if you actually count up how many p's that is, that's p to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how it works. You don't necessarily have to write out all of those p's. That was more as a proof to show you why this actually works the way it does. So you can just add together the 4 with the 5 to get p to the power of 9. Nothing changes about the base. The base absolutely fundamentally stays the same. You only change the exponent. Let's look at another example. So this one we have y to the power of 3 times y to the power of 6. So remember the instruction. You keep the base, so nothing changes about y, and then you add together the exponents. So you add together the 3 and the 6, so that gives you to the power of 9. Pretty simple, I hope. So let's have a look at the second index law. The second index law has to do with dividing powers. So when we are dividing powers that have the same base, again, that same base, that's key. You have to have the same base, or else this law does not apply. You keep the base, so nothing changes about the base, and you subtract the indices, you subtract the exponents. So what does that look like? Okay, if we have p to the power of 7 divided by p to the power of 3, what does that actually look like? Well, p to the power of 7 means p times p times p times p times p times p times p. We have 7, 1, 2, 3, 4, 5, 6, 7, a little messy in the middle, but we've got 7. So that's all divided by, so that's all going to be over p to the power of 3. So that's 3 p's. 1, 2, 3. Now, if you divide anything by itself, what's the result? 1. So if we divide this p by this one, we get a result of 1. So in effect, that kind of cancels itself out. So we have p divided by p, that gives us 1. If we look at the second one, that also cancels out. We look at the third one, That also cancels out. Now all of a sudden we don't have any p's left on the bottom. All we have left on the top, although messy as it might look, is 4 p's. So we can think, okay, well that's p, crazy looking p, that's p to the power of 4. Messy as it is, it's p to the power of 4. So if you look back at the question, think about the law. The law said you leave the base alone, you subtract the exponents. So 7 minus 3 is what gives us our power of 4 in our answer. Let's look at another one. A to the power of 6 divided by a to the power of 5. So think about the law. The law says don't change the base, subtract the exponents. So 6 minus 5 gives you a power of 1. Now we don't usually write that power of 1 because if you have the a there to begin with, you know you have one of them. So usually we would just write that as a final answer of just a. Let's look at the third law. Third law has to do when you're multiplying a power to a power. So you have a power and then you want to raise that to another exponent. You want to raise the index on it. So raising a power to a power, keep the base. Remember that base, we don't touch that base. And then we multiply together the indices. So if we look at something like b to the power of 4, all of that to the power of 5, I would write it all out, but that's a lot of b's. So think that's b times b times b times b 5 times. So the law says keep the base, and then we multiply those exponents together. So 4 times 5 gives us b to the power of 20. Not too difficult. Let's look at another one. A to the power of 7, all of that is going to be cubed. So we keep the base the same. We multiply together the exponents. 7 times 3 gives us 21. So a to the power of 21 would be your final answer. So what happens when we bring it all together? When we put everything, all the rules at once? The key to remember here is just do it a piece at a time. Start with your numbers and then literally go base by base. So letter by letter, working it out one piece at a time. So if we have something like 2b squared times 3a squared b cubed, piece at a time. So number by number, so we have 2 times 3, that'll give us 6. Then go to your a's. We have no a's in this first one, and we have 2 in the second one, so we have a squared. So that will be our a piece. And then we have b squared times b cubed. Remember, bases are the same. When we're multiplying, we add the exponents together. So this becomes b to the power of 5. Let's look at another one. So 6x to the power of 4y cubed. All of that divided by 3x squared y. So number by number. So start with the 6 and the 3. So 6 divided by 3 gives us 2. And then we have x to the power of 4 divided by x squared. When we're dividing bases, when dividing powers when the bases are the same, we subtract those exponents. So that will become x, and then 4 minus 2 gives us 2. And then we have y to the power of 3 divided by y. Remember, even though it's not there, you imagine that there's a power of 1 on that y. So dividing powers, bases are the same. Leave the base. So we leave our y, and then we do 3 minus 2 to get our exponent on it, so that would be to the power of 2. So our final answer would be 2x squared y squared. Okay, that's it for this video. Hope you've enjoyed it. Thanks.